In this video we'll be looking at the new automatic geometry preparation and meshing capabilities in Femap. One of the biggest obstacles in the process of meshing geometry to create an accurate finite element model is that quite often the geometry itself contains disruptive entities. Items such as sliver surfaces and short curves may not affect the serviceability of the model for CAD purposes, but they do pose problems when trying to create a mesh. In this model, using Femap's meshing Toolbox Locator function, we've identified a couple of sliver surfaces which, if left alone, will lead to the creation of very small elements in the area of the slivers. We can measure the width of the sliver to get an idea of the dimensions involved. If we are not interested in capturing this detail, we can have Femap remove these slivers and create a mesh as if they didn't exist, completely automatically. In the Mesh Geometry Preparation menu, we can control various aspects of geometry preparation and mesh sizing to heal problematic geometry and control subsequent meshing. In this dialog, there are sliders that control the geometry preparation and mesh sizing tolerances, and we can click Prepare Options to access further controls. In the Geometry Preparation Options dialog, we can control how much geometry will be affected by the automatic cleanup process through maximum sizes and angle settings. These are based on the geometry preparation tolerance. We can also specify which preparation options to execute. These deal with the various types of geometry problems that may exist, such as slivers or points close to an edge or surface. These values have been tuned to deal with most geometry problems that are likely to be encountered. Femap prepares the geometry based on these settings, and if we zoom in on the model, you can see that in this case the top surfaces around the slivers have been combined together. Now with the geometry fixed, we can go ahead and mesh the model and view the resulting finite element mesh. An inspection of the final mesh shows that the sliver surfaces have been ignored and the model meshed without them. Looking at the mesh quality report in the messages pane, you can see that Femap has created a very good mesh where the worst element has a collapse ratio of only 15. So the automated geometry preparation capability will ensure that the model will mesh to create an accurate and efficient finite element model first time. To find out more, visit us at siemens.com/plm/Femap or call your local channel partner.